Welcome to Speakeasy JS, the JavaScript meetup for mad science, hacking, and experiments. I'm Faraz, and I'll be your host this afternoon. Mad science is about building things that make people say, I didn't know that was possible. So at Speakeasy JS, we like to feature weird and wacky experiments and not ready for production projects. So if you have a half-baked hack or a boil the ocean project you'd like to share, just please send me a note. My email is faraz@faraz.org, and we'd love to have you on Speakeasy to share what you're building with us. And one more thing, if you're enjoying Speakeasy JS every week, please help us spread the word. So if you could go right now to Twitter or your favorite social media site and share the link to this stream, it will help people find us and spread mad science far and wide, which was always a good thing. So today we are joined by Andrea Giammarchi, and he's from Italy and coming to us from Berlin. And Andrea is a prolific NPM developer. I was just looking through his NPM page, and he has 400 plus NPM packages, which is just amazing. I think he's particularly proud of micro HTML and micro hooks, which are UHTML and UHooks on NPM. So you can check that out if you're interested. And sometimes he works on standards from time to time and helped out a little bit with the ESM definition on Node.js. And I've definitely used some of your packages, so I thank you for publishing those. And your GitHub name is Web Reflection, so if other people have stumbled upon that as they've been developing things, that's who you are. That's your username anyway. So anyway, thanks for joining us this afternoon, and it's actually 1 a.m. for you, isn't it? Over in Berlin right now. Sorry for doing this to you, but we're really happy that you could join us, even if it's that late.
It's okay. It's Friday, so it's fine. I can survive. Thanks. Thank you for us for the introduction, and also for inviting me to talk here. You forgot to mention that from time to time I also drink JavaScript, and that's what I do now. And this if you want, I can start with the presentation right away, and so we have time for some benchmark and everything else. All right, I'll try. So, well, Frost already said pretty much everything about me, and there's not much else I would like to say. It's just that when I see challenges and things that are crazy a little bit, I usually think, why not? Let's try that, even if it makes no sense. And this is a talk about this latest project, which is exactly about not making sense, but that somehow worked out. And it's called Linkdom. And the story of Linkdom is that, first of all, there are libraries that I'm using this template. I'm hacky with the template literal strings and tag and template literal tag functions since 2017. And this is what this library do. Basically, this library are like just-in-time compilers for this kind of content. And what they do, they map all the interpolation value, in this case value content, all these kind of interpolations are mapped somehow in a way that every render, every update only targets a specific attribute per node or specific content. And so all the static parts around never change, nothing happens, and so the updates are blazing fast. At least that's the idea. And more about this, how does it work? Basically, the template is created with this content only once, because template literal tag have this template first argument that is always unique. And so you can use a weak map, for instance, to decide to map this kind of template only once and map all the attributes and content that needs to change once. And to do this, you start crawling all these nodes inside this fragment. And if it's an element, it crawls the attributes, and then it goes into the element, check for content, and then the dance repeats. So if it's an element, checks the attributes, go in, go out, check other elements, and then until the end. and then map all this value per attribute or per content. So now I'm gonna make it this slightly smaller so you can probably read or probably not. But basically, the dance that these template libraries do, and there's UHTML, it could be lighter HTML, it could be hyper HTML, or I believe lit HTML is doing a similar dance as well. So all these kind of libraries do similar things. And this is just the beginning. So meanwhile, a few days ago, there's Linus Torvalds reached top spot in Hacker News one more time, and I'm pretty sure he wouldn't mind if I mention him in this talk, which has nothing to do with what he does daily. I'm sure about that, right? So what was this post about? It was about good taste in programming. Obviously, he's a long-time C lover, and so this talk is more about JavaScript, not C. So let's see the version in JavaScript. Basically, L is a linked list. Target is some node within this linked list that we would like to remove. And this is the classic CS 101 dance. So we take the head of this linked list, and we have a previous value, which is null, and then we look for the target, and while the target is different from the current node, we go current next, current next, current next. Then if there is a previous value, it means that the target wasn't the first node. So the previous value next will point at the current next, and current next is just the target next. And otherwise, if there was no, if current target was the same right away, it means that it was the head. And so that means that the next will be current next. And so basically, this is a way to make the target go away from this list. And the elegant way to do this in C, and then I will show also the JavaScript version, because this is more about JavaScript than C. But basically, the elegant way is that you don't need that if-else dance, because in C, you can directly point at the address memory that is the next or the head. So basically here the pointer is for the head, and while this head is different from the target, the pointer goes to the next pointer of the next node, and at the very end until it reaches the target. And at the very end, basically what gets updated is directly next of the previous node that wasn't target. So this is a bit, if you're not familiar with C, this is cool and weird at the same time. But basically in JavaScript, if you want to simplify this, it means that you have this reference and you don't need this previous, dance, current. You just keep going, checking for next, and then you eventually drop the target, and whatever next was at the target will be the next node of the current list. In this case, I've simplified the code because the head, it makes no sense in JavaScript, or it would have made the code bigger. So enough of this C good tasting programming talk. All these linked lists, so there were a lot of comments about why linked lists are cool, why linked lists are great. And this made me think if I could use this linked list, because here we are seeing just one element, one target removed from a linked list. But what if it's an entire fragment? So a collection of already linked node, and so the operation is just to find the first one and then connect the edges of the outer list to the last one. So you could actually move around a lot of nodes doing just few operations. And so what if I can apply this same concept to a DOM tree? So we see the tree, but what if we can traverse the tree with a while loop? So it doesn't matter how big is the tree, it doesn't matter how convoluted it is, it's just everything is connected to each other. A single while loop that will scale no matter how big is the tree, no callback recursion, nothing like that. What if manipulating this tree has cost almost zero? It's like updating the two boundaries of these nodes, of this fragment that we can move around. And what if literally everything is a link away? That means that next sibling, previous sibling, you have the node and you know already if there is a next or a previous one because it's a linked list. So we all know that in JavaScript references are basically everywhere. Every time we pass an object, the object is by reference. So and also pointing object to other objects is relatively cheap. And on the other side, arrays, if we start the push operation with arrays is pretty damn fast. But if we use like unshift operations, splice operations, so these are kind of slow compared to just update this property and point at something else. And also arrays have linear access, direct access to their index. They are very, 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 very fast. While, as we have seen before, just to find the target of a linked list, we need this while loop from the head of the linked list every single time. So does it make even sense to try this linked list for DOM? Well, what I've done, or what I thought was worth trying, since you can consider HTML like we parse as a string. So HTML is just a string, which is an array and a fixed size, and we crawl the string and we create this DOM. But after all, at the very beginning, HTML is born as a string content. And so if you can flatten out, we can see also that basically it's a string and there is no tree. So it's just, we can just keep going and going and going and going. The tree is the result of the parsing, but there's actually technically no tree at all. And if we look closer, it's also already kind of sort of a linked list. So we always have this container and then attributes and then some content and then eventually another container or element with eventually attributes, some other content, and so on and so forth. So this obviously looks exactly like a linked list. There is only one thing missing, and that's where I had to think about the issue that you can overflow constantly. If you have this kind of structure, you will always overflow the boundaries of the node. You don't know actually where the node ends, so you cannot understand the child nodes. You cannot understand the next sibling of an element, and so we need to fill with some crap that gap. And so this is how the idea came of a node type that is -1. So it's a node type that is not used in the standard, and it clearly states that the node element is closed, or the fragment. And in a nutshell, so basically a node can be an attribute, a text, a comment, an element itself, and the node have boundaries, left and right. There could be or could not be other nodes. So the different with the element is that we need that crap that I mentioned before, and this element has an end. And as you can see, these are all double linked lists, left and right. But in the element case, there is a triple link, which is between the element and its end, so that at any time during any operation, I can quickly reach the top of the element and then eventually reach the end of the element, so that all these next sibling and previous sibling can be simplified. With the attribute, we follow the same convention. So basically, the attribute is always at the beginning of the element, meaning that if I add an attribute to an element, it doesn't matter what's inside the element. I just place that attribute node between the element and element next. Whatever is next on the element, in this case, there was nothing in the element, so it was the end node. So the attribute goes right between the element and its end node. So it's just a matter of adjusting boundaries and linking those. If I want to append a node or add a node, I just reach the end of the element, and whatever it was previously there as a node, so the previous node, it could have been the element itself or one of these or its last attribute, and then the node is just placed right away there. So we just plug, update these two links, and that's it. There's nothing else that moves around. And so a new attribute followed the same. It actually, instead of shifting or moving or pushing attributes, I just placed this new attribute in between the element and whatever was next. And the same goes for the node. So the node is always, if I have to append, is always before the end of the element. If I have to insert like as a first child or insert before the first child, the while loop will check from the element on the right that there are attributes, will skip all these attributes and will just place the node here, no matter what's after. It could be the end or it could be some other node. And that's pretty much it. And while all this ASCII art to represent these triple links might look weird, if we think about a JSON representation of the same concept, it's basically an array. It's always an array. It's linear, and it has these conventions. So the node type at the beginning, then if it's an element, like in this case it's a tag, the node name, 0, 1 or more attributes or nodes, whatever. And then since it's an element, it closes itself with -1. And the attribute has node type 2, a name, and optionally a value. And the text or the comment have node type, respective node types. And then either their text content or the comment content. The document has just a node type of 9, sorry. 0 or more other elements, and it closes itself as a fragment with -1. The doc type, when we write doc type HTML, for instance, has a name. So the node type is 10, and the name is HTML. And a fragment has node type 11, 0, 1 or more content, and then it closes itself with -1. And this should look better if we spread all this information into a single array, so it can be theoretically streamed and parsed at runtime very quickly, because there are also no need to escape HTML, because there's no HTML around. It's just all the information that we want. And the cool part, if we think about a classic HTML document where you have HTML head, body. When the body ends, there is a -1, but the body ends and the next node will be the end of the HTML as well. And so this structure or this schema allows me to collapse the ending. So if I have a big tree that they are all ending, and at the end of some node, internal node, or at the end of the document, basically I can have -2, -1, -10, -11. It doesn't really matter. And so that makes it also slightly more compact in terms of representation. Although because of gzip compression does a very good job with HTML, this is not necessarily shorter or smaller, but it's surely a format that can be quickly shared across any environment because it's JSON, and it allows an environment also to recreate the structure with ease. And back to the basics, though. So in computer science, we know that arrays are linearly accessible and they are super fast. While on the other side, the linked list, which is all these links that I'm trying to make sense of, they require more space, because we have a value, but the value is also associated with where to find the next value. And so linked lists theoretically are a bit slower because we do a while loop instead of accessing directly an index, and also theoretically they are heavier in the memory. Then this is true in C, and so in JavaScript, I don't really know how it works behind the scene, because the engine removes a lot of these kind of problems, or solves a lot of problems for me. But theoretically, nothing should work properly with this linked list idea, right? So here's the thing, though. If we think the classic next sibling that I previously mentioned, operation. So imagine you have to write with JavaScript an next sibling operation. You still need from the node a reference to the parent node. So there is already a reference, and the parent node, let's assume, exists. And so there is a child node. And then we need to find the index of the current node. When we access the next sibling, we want to know where is the current node. We add 1 to this index, and then if the new index, the current node plus 1, is within the child node's boundaries, then it means there is a child node to return and will be that index plus 1. Otherwise, it's null. And this is actually not super fast, because we need a reference anyway. We need a linear search through the child nodes, and we need to compare with the length, and then eventually we return it. This is the zero cost operation or the O1 operation. Otherwise, it's null. If we look for next sibling with this linked list idea, first of all, as you can note, I don't even need to check the parent node. I just need to check that if the node type is 1, it's an element, I can go to its end. Otherwise, it's just the node itself. And then I take the next. Here I'm destructuring next from the right node. And then if the next node type is less than 0 in this case, or is -1, or is basically an end node, meaning that the next node of the body, like I've said before, if the next node of the body is the closing node, the end node of the HTML. So in that case, it means that there's surely no other next sibling to the body. So in that case, it's null. Otherwise, I just return next. So this is the theory. So the crawling should be slower, but the manipulation should be actually, hopefully, faster. And now I'm gonna show. I have to apologize in advance. I didn't make the font of my screen of my terminal too big, but I will walk you through what I'm doing, and maybe you will realize why the screen is like this. So to be fair, there are not many options we have when it comes to SSR and JavaScript. When you want to manipulate the DOM properly, or you want to do a lot of things with the DOM, we have basic HTML, which is something I've created just to fulfill some performance need I had with the Viper HTML, which is an old project for SSR. And then we have JS DOM, which is pretty much universally known and is also used to test a lot of things. And so it's very bloated in terms of features, because it tries to respect as much as possible the entirety of the HTML specification. So I take the W3C document, which is a 32K page, and I try to see if basic HTML was performing good enough. And indeed it does. In 1 second, it's just blazing fast, and that's okay. And then I compared basic HTML differently from Linkdom, is using attributes as an array and child nodes as an array, which is, I think, pretty much what every other library is doing today, and also JS DOM. So I've tried with Linkdom, and I couldn't see anything interesting. And then I tried the JS DOM, and here I had a surprise, because JS DOM does a lot of things, including parsing CSS, JavaScript, and all the kind of things. And there's something is not happy about the W3C document, but that was not fair, because I want really to compare against JS DOM. So I took the DOM specification, which is 2.7 megabytes document, and in this case, I've tried JS DOM again, and basically, what I'm benchmarking here is how long it takes to parse the document. And I know JS DOM does much more, because it parses string CSS, scripts, CSS, and everything else. And so that's kind of unfair to compare, because Linkdom doesn't do that. But also how long it takes to crawl nodes and to modify nodes, to clone the entire document. And this is 2.5 megabytes or 2.7, more or less. And here I'm removing like 800 divs, and it takes 270 milliseconds. So if I compare with basic HTML, it's much faster at doing everything else. And to remove divs, because it doesn't have mutation observer, it doesn't have custom elements, it doesn't do much. So removing divs takes 1 millisecond compared to JS DOM. So here it was more interesting, because I wanted to try Linkdom. And Linkdom is already a bit faster here. It's removing the same amount of divs in just 1 millisecond. And now let's try the big monster, or the elephant, that is the HTML single page specification. It's like 12 megabyte document, which is the homepage of the specification. And I suggest nobody to go there directly and use the multi-page version, because this is very, very heavy. And so let's see what happens if I try to parse that document with JS-DOM. And this is where things become more interesting, because JS-DOM can take just about forever to parse this document because it's huge. So it took 11 seconds. And if we think about using these tools on the server or in Lambda functions, if we think about that, we spend money also for the CPU, how long it takes, how much RAM we need. And here is already greedy, is already 1.5 gigabyte of RAM, and it's very, very, very slow. Now, I would say that it's not something we should propose to web users, to our users, to have 12 megabyte documents. But what's not cool at all is that JS-DOM at some point crashes. And so we spent a lot of time to end up with a crash that give us nothing. Okay, JS-DOM, I cannot compare that. Let's try with basic HTML. And basic HTML, it's surely faster, and it's super fast at crawling child nodes, but it gave me a lot of maximum call stack size exceeded. So basic HTML, basically, pure not intended, is pretty much useless for anything more complex than some small template literal that is what was created for. But then I check Linkdom, and this was the biggest surprise. So with these 12 megabyte documents, Linkdom didn't sweat as nothing. And also, now that I'm streaming, live sharing, and testing this, it took 5 milliseconds to remove 3,000 divs. So to be even more fair, I wanted to remove the clone node, because I know that JS-DOM had issues cloning, and that's why cloning the 12 megabyte document crashes. And so without cloning, let's see how well JS-DOM performs. And now you have to bear with me, because the initial parsing time is still close to 11 seconds or whatever it took before, 12 this time. And then it's normalizing the document, it's crawling child nodes, and it takes almost 3 seconds to do that. And when it comes to removing these 3,714 divs, well, this is painful. So let's say that the manipulation, DOM manipulation is in JS-DOM is almost forbidden, because it's super slow. It took 20 seconds or something. If I use the same benchmark with the LinkeDOM, you can see that things are slightly different. So now it took 4 milliseconds to remove all the nodes, and the results are the same, and the memory consumption is ridiculous. Now, before I finish this presentation, bear with me another minute, because I wanted to compare the minimum viable DOM implementation to just a doc, to just fulfill this benchmark I created based on this JavaScript document object notation arrays and what I've explained before. There is this project called JS-DOM, and this project just is not really mature. It does nothing, but it creates the minimal amount of structure with attributes as an array and child nodes as an array, and then it's super fast compared to anything else. At crawling, at parsing, at generating a document, but it doesn't have custom elements, it doesn't have mutation observers, it doesn't have anything that can slow down operations, and yet, when you check how long it took to remove divs, takes like 10 times more than Linkdom. So that kind of proves that not necessarily Linkdom is the best approach for DOM in general, but it proves that for some specific use case, like quick swap of nodes, DOM manipulation, removing child nodes, updating child nodes, it can be actually quite a game changer. And yet, I think I will not stop exploring the possibility to have this very small, efficient, tiny DOM parser for the server side, because I'm using this with a few libraries, and performance on the server side is super important. So to finish, first of all, thank you again for inviting me and for listening to this talk. And this is just the few things that Linkdom is already capable of doing. There is a mutation observer, 99% working. Something is not implemented, like if you change some text, I'm not observing that yet. Custom elements v1 fully implemented, included built-in extents. There is tree walker, query selector all with proper CSS selector, a proper engine, and it's pretty fast. And then there is also an optional cache. So if you have a document that you want to query multiple times and you don't manipulate it much, the cache makes it like consequent operations or crawling extremely fast. And so you see results in a 12 megabyte document, like it takes 0 milliseconds or something, events, listener, SVG, and more. And yeah, I think I managed to say it all, and probably it took too much, but I'm done. Thank you again.
That's amazing. Well, thanks for sharing all that with us. That was a very like rigorous talk. Like I liked all the CS, the computer science review in there. Good blast from the past. So if people have questions for you now, this is the time to post the questions in the chat, and I'll go ahead and ask Andrea for you guys. So feel free to do that. But in the meantime, I want to ask you some of my questions. So I'm curious.
Yes.
What sparked your interest in this area? What got you so interested in building a package like Linkdom?
So basically, I have these SSR-oriented libraries that share the exact same components, logic, and idea of the front-end side, of the client side. And to do that, even creating custom elements and stuff like that. The most popular, or no, it's not even popular, it's just the most probably known library that does that is called Heresy. And Heresy SSR basically lets you create anything you will do with the DOM, and it transforms, makes disappear things. So it's some sort of hybrid approach between what Svelte does and what JSX does. And it's using this basic HTML, which was at the time the only option I had to not use JSDOM, because JSDOM, I know it was slow. And so I wanted to have something faster, because SSR with JavaScript is becoming more and more popular, and having some way to have a real structure that you can query, you can dispatch events, you can and move even on the, I don't know, change the layout constantly without reparsing things all the time or recreating all the strings. It's working well with the Heresy SSR, and it worked well with Viper HTML, but it's limited with basic HTML, because basic HTML was half of a joke as a library. It was just a quick hacked solution. And I thought, okay, maybe we can do something better, and maybe this something better can scale more and do more things. And so, and also worth saying, I use these libraries to test my front-end libraries as well. And I don't want to wait forever every time I want to run a lot of tests. So if I have to run 1,000 tests to be sure that UHTML is working properly, I want the best library that is reliable, because I want to use Node.js. I don't want to spin up a Chrome instance every time. And yeah, and so that's for me a game changer, because I just npm test and boom, done. I covered 100%. Go on. There are few other use cases that I have in mind. But I don't want to share right now this. But yeah, there are a few applications, and as long as performance and memory is good, memory consumption is lower, and performance is good, I think new projects can come up with this library.
Nice, that makes sense. Yeah, I used to use a DOM library. It's not very popular. You maybe haven't heard of it, but it's called LinkeDOM. It was by Jason Miller, or Develop It. And I was using it because it was in some of his pre-act examples. And it's similar. I think it was similar in design to maybe basic HTML, which is your package, which is like the minimum, kind of a minimum viable implementation of a DOM for the server. Yeah, so I remember trying JS DOM and then comparing it to UNDOM, and I was like, wow, the speed difference is huge. So if you're doing SSR for every page, it's really important. So that makes some sense to me.
Yeah. Also, Jason is as maniac as I am with the code sites as well. So he does a lot of minimalistic libraries that are pretty snappy and small. And so I will try to check UNDOM out, because I'm sure at some point I heard about it, but I kind of realized today there was something else, and that's good to know.
Yeah. So was there any other prior art that you built on, like when you were building this, that you, I mean, I guess you just mentioned all of your different previous attempts that you worked on, but I guess I'm just curious, like, how did you know this was going to be performant? Did you know that this approach was going to work? It sounds like it was a random
no,
idea.
It was a random idea, and but what got me excited is that while I was thinking about this idea, I create this JSON JS DOM, which is this way to serialize the entire tree and store eventually and recreate a tree and move the tree around different programming languages, even if it's needed. And that's actually not only cool, but it's super fast in both creating this structure, moving the structure around, and recreating back what was there before. So for snapshots, it seems like it was just a demonstration that the idea theoretically of this linear DOM made sense. And then performance, until I tried, I couldn't imagine what was going on. But the very first implementation is documented in the GitHub repository, and it explains the most basic simple test that I've done, and it was 60 lines of code. It wasn't too big or nothing too crazy, but that worked very well with the first attempt of parsing and using this structure instead. And then obviously, as soon as you start putting in custom elements, so you need to be careful with all the mutation, because you need to trigger the right thing, or mutation observers. And mutation observer, if you have a lot of mutation observer, can be painful no matter what kind of wizard are you using. It's just a lot to dispatch, a lot to check, and then hopefully also there is this invalidation from the mutated thing to the top parent, because if you cache a query selector role, you cache something, you want to cache as much as you want if you don't mutate, but as soon as you mutate, all the cache must be busted. And there are a lot of things that become easily very complex, and I guess that's why we have cool people working with browsers, and there are not so many browsers out there, because things are super complicated super soon.
Right. So there's a question from the audience here. I'll ask now. It's I saw you had events. Do you stringify them as well? If not, is it easy to hook into stringification?
In terms of so on the server side, basically events disappear when they are rendered, because you can't bring the scope of that event function within the code, or at least I haven't found a way to do that. And unless you want to stringify events, but that's a different matter, because you have this function, or this function body that is self-contained. It doesn't leak, it doesn't use reference from the outer scope, and is self-contained. And in that case, you can just inline as a string the event. Although what's best to do, and something that I'm willing to try to do with the Heresy SSR or UHTML SSR as well, you could combine a lot of events into a body function apart. And then if you can address somehow all the nodes that had this event, you can basically offload the layout, the HTML, but at the very end of the stream, you can use some JavaScript created at runtime that address all the right nodes and put events with the whole scope. But that's more complicated than, it's more easier to say so than doing it. But yeah, if you want inline events, you need events that can work as a string. And that's not difficult, but if you have all strings as event in a big layout, it's going to be a lot of bandwidth.
Interesting. There's another comment from Tiny Fluff. It's kind of a comment. It says, they say that JS DOM format is quite interesting, and I imagine it would serialize very nicely as a CBOR stream, avoiding JS arrays even more when processing it. It's fun to imagine an object stream that takes in linked list elements on one side and outputs HTML string streaming on the other side, or vice versa. That's kind of an interesting observation.
Yeah, the idea is there, is fairly new, but the library, the JS DOM, is an NPM module as well, and it's linked in the Linkdom README. There is also a link to the JS DOM, and yeah, I think it opens few possibilities, and it doesn't even have to be JSON, but the structure is clear. So you have a byte for the node type, and then accordingly to that byte, you can keep parsing and keep parsing and keep parsing, and you end up with a tree on the other side, and you don't need to know the end of the tree while you keep parsing and adding things, because as soon as you have a negative information there, then you reach out the parent node or whatever parent node was there. And so yeah, I think it's interesting, and it's super fast. So with Linkdom, actually, if I go in this HTML specification 12 megabyte documents, and I try to use JS DOM there through the native, all the native accessor like child nodes, attributes, node type, it's slower on Chrome to create this JSON stream than it is with Linkdom. So that's why I think it also has potential, because the structure itself, the way it's parsed, when you don't have all the primitives on the browser, it's super fast, and you don't really need to recreate all the capabilities that has a browser from the stream. You can just create a much lighter structure, a much lighter stream. Like the last benchmark I've done, it really creates only attributes by an array pushing, and nodes by child nodes, and it's super fast. So I think there could be more implementations or more ideas out of this stream. But yeah, I like the fact that it's linear, so it can be streamed and can be represented in many ways.
Cool. Well, I think that's all the questions that we have time for. So I just want to say thanks again for presenting this to us and for staying awake. It must be 1:50 a.m. there, almost 2 a.m. Wow.
Yeah, I had 3 coffee, 3 coffee before the bed.
Oh gosh, I hope you're going to be able to sleep after this.
Maybe. Thank you again. I hope I've answered somehow your questions, and yeah, I'm happy something was interesting about this talk, and yeah, thanks again.
Yeah. Totally. And yeah, it's been great to see your presentation. So just for the viewers this week, I want to mention that we're not going to be doing the social happy hour after this talk, because Andrea needs to go get some sleep. So we're going to skip that this week, which is I think a fair thing to do. So yeah, we'll resume that next week. So if you want to come back next week and join us, we have another talk as usual. Next week is going to be from Gabrielle Furstenheim, who's speaking about infinite mosaic, infinite tiling of artworks, which is a talk about those I don't know if people are familiar with those websites where you can sort of zoom into a piece of art And then as you zoom in, you can basically zoom infinitely. It never ends. It kind of, as you zoom in, the art repeats itself, and it's recursive. So he's going to talk about that and how he implemented that. And so that's going to be really interesting. I have no idea how that works. I'm looking forward to that next Friday, same time as usual. We always meet Fridays at 4 p.m. Pacific time. So see you all next week. Thanks again, Andrea, and I hope you sleep well and get all that coffee out of your body. Thanks again for staying up for us.
Thank you all. Thanks. Bye.
All right. Bye-bye.